Exponential models in recursive form. A recursive definition has two parts. First, it has an initial condition, which is the value of the first term. Second, it has a recursive formula, which relates each term after the first term to the one before it. So let's look at this first example. The table shows the number of subscribers to an artist's photo sharing account over a period of several months. Write an explicit formula and a recursive formula to model the data. Let's first look at the explicit formula. So what we will first do is write each term of the sequence with an exponent and look for a pattern. So our first term, a sub 1, is 7. Our second term, a sub 2, is 21. So I'm looking at these numbers right here in the table. This is my sequence. My third term is 63. My fourth term is 189. And my fifth term is 567. I can write 7 as 7 times 3 to the 0. I can write 21 as 7 times 3 to the first power. I can write 63 as 7 times 3 squared. I can write 189 as 7 times 3 cubed. And I can write 567 as 7 times 3 to the fourth. So each of these exponents, 0, 1, 2, 3, 4, goes up by 1, or differ only by 1. So that means my explicit formula can be written as a sub n equals 7, which was the initial value, times 3 to the n minus 1 power. Let's now look at our recursive formula. So first, we'll write the first few terms using the previous term. So a sub 1 was 7, a sub 2 is 21, which can be written as 3 times 7, or 3 times a sub 1. A sub 3 is 63, which can be written as 3 times 21, or 3 times a sub 2. A sub 4 is 189, which can be written as 3 times 63, or 3 times a sub 3. So for our recursive formula, our initial value, a sub 1, is 7, and our recursive formula is a sub n equals 3 times a sub n minus 1. The next term equals 3 times the previous term. Okay, let's look at a second example. The function y equals a times 2 to the x models the number of E. coli cells y in a petri dish x hours after the start of an experiment. Write a recursive formula to model the situation. So let a sub n be the number of cells after n hours. Then let's write the first few terms and look at a pattern, or look for a pattern. A sub 1 is 8 times 2 to the 1, which is 16. A sub 2 equals 8 times 2 squared, which is 32, which is 2 times 16, or 2 times a sub 1. A cubed equals 8 times 2 cubed. Sorry, that was a sub 3 equals 8 times 2 cubed, which is 64, which can be written as 2 times 32, which is 2 times a sub 2. A sub 4 is equal to 8 times 2 to the fourth power, which is 128, and this can be written as 2 times 64, which is 2 times a cubed. 2 times a sub 3. That means our recursive formula, we'll write first the initial value, a sub 1 is 16, and then the second part, a sub n, equals 2 times a sub n minus 1, or the next term equals 2 times the previous term.